Okay, it's 8 o'clock, so I'll start. Oh, nice. All right. Um, Welcome everybody to a webinar today, hosted by PlantGrads. We'll begin in just a minute. But yeah, while we're here, I'll just say if it's first time to coming to a PlantGrads webinar, we try to host a number of webinars like this, primarily focused towards either prospective graduate students or current graduate students. And you can check us out at our website, plantgrads.com, as well as our link tree. We have other socials if you want to stay in the know on those kinds of webinars. But today we're very excited to be having two amazing postdocs, Dr. BeKa Leuschen-Kohl and Dr. Taymee Brandon. Dr. BeKa is coming from University of Kansas, and Taymee is coming from Princeton University. And they'll be talking about navigating graduate school, going over different programs and funding types. And hopefully this will be really informative towards people who are interested in graduate school and want to learn about kind of what are some of the expectations there. And so I'll let them kind of take it away from here. And yeah, I hope everybody enjoys.
Thanks, Wesley. We're really excited to be here. So as Wesley said, I'm BeKa and my friend Taymee is going to be joining us today. We're going to talk about different programs and funding types. But first, we just wanted to give you a little bit of background on who we are and our program, which is called Gateways to Graduate School. So again, my name is BeKa, and I'm currently an NSF postdoctoral fellow at the University of Kansas. But I bring a little bit different experience than Taymee, so we're going to kind of overview that, which gives us kind of an understanding of the generality of different types of programs of grad school. So I got my Bachelor of Science at the University of Nebraska and went directly to my PhD program at Purdue University, where I did rotations in the quantitative plant pathology program. And then I went directly to my postdoc here at the University of Kansas. Taymee?
Yeah, so hi everybody. My name is Taymee. I'm currently, I guess, starting in like 2 weeks, a postdoc at Princeton through the High Meadows Environmental Institute. My work is not in the plant sciences. I'm more in this aqueous contaminant remediation space, so maybe implications in plant sciences, but so my path has also been a little bit different from BeKa's, so I feel like we sort of complement each other. I got my bachelor's in chemistry from the University of Montana and worked more in an analytical chemistry type lab. And then I actually took a year off between undergrad and grad school. I wasn't sure if I wanted to go to graduate school. And then during that year, I decided that I did, and I applied and joined a master's program at Montana Tech in environmental engineering. So I did a little bit of field switching at that time. And then I had originally thought that I would do a PhD in chemistry, but during that program with environmental engineering, I decided to continue on where I pursued my PhD in environmental engineering at Purdue University, where I just graduated last spring. So our combined experiences then kind of inspired both BeKa and I to create this Gateways to Graduate School course where we were able to teach and sort of complement each other and then, learn a lot about applying to different programs. So then, leading into our agenda, today we will be introducing you all to some of the expectations, terminology, and then general aspects of graduate school that can kind of help orient you as you move on to next steps after your undergraduate education. First, we're going to discuss some questions and strategies to help determine if graduate school is even the right move for you on your career trajectory. And then in order to help kind of demystify some of the different types of programs that are available in graduate school, and then explain, if you are in a program, the different types of funding that can be available to fund your graduate education. So it's important to note that this webinar can serve as sort of, an introduction to understanding different programs and funding types. But, every university program and person is different. So just be sure to follow this with some additional, learning, research, and conversations as you pursue graduate education. So then next slide. So the first question being, is graduate school the right move? And it's important one to ask yourself, at any stage during, undergraduate education, or if you graduate, you can ask yourself that later if you decide to go back. And then we start thinking about, next slide, what graduate school is really like. And when you think about graduate school, you may have some impressions already from interacting with graduate students, either, in a research setting or, TAs you've had, or just even, being in classes with them. I know when I was an undergrad, I thought that grad school was basically just, a more difficult undergraduate degree. However, the outcomes, the daily experiences that you may go through, and the path that you're on kind of differs greatly between undergrad and graduate school. And it can even vary a lot between the different types of graduate education or where you may go. Um, One way that they differ is that, as an undergrad, your expectations and timelines tend to be more structured. However, as a graduate student, there's often a framework and deadlines, but a lot more flexibility that you're making with your own schedule that kind of causes everything to be a little bit more of a balancing act. And so there's a saying that, you wear a lot of different hats. That's very true in graduate school because you'll be balancing different things like classes, presentations, trying to stay updated on the current scientific literature, doing lab work. You might possibly be teaching either as a TA or if you teach your own course, grant requirements, if you're funded through a grant or you're applying for grants. And then, of course, your personal life, wanting to maintain that level of work-life balance. And then many other things not listed here. So graduate school tends to be very different than what you envision once you're actually in that situation. So then some questions you might want to ask when you're, thinking about whether or not graduate school is right for you. One of those being is, what is my career goal? Once you have an idea of what it is that you want to do, you can kind of work backwards from that and see what degree or what experience gets you to that position. Sometimes it may make more sense to pursue a professional master's if that would help you meet your goals, or sometimes a PhD might make more sense if you're interested in, doing some sort of government position that requires that, or you would like to be a professor. So then you can start thinking, have I talked to someone already in the program? Because by reaching out, you can get a lot of insight into that. If there's a program that you're particularly interested in, talking to someone who's in that is one of the best ways to gain knowledge on the program. And then beyond reaching out to students, you can ask, have I reached out to any, potential labs or PIs, taking the time to reach out to PIs, talk to them directly and kind of seeing if, you're a good fit or what that program might be like can be useful. And then also, have I looked into application timelines and deadlines? Because you want to make sure that you're aware of all of those really well in advance. Because preparing the materials can definitely take a lot of time. So you want to know that, that makes sense on your during this current year, if it would make sense to apply next year. So you want to think ahead and be prepared for that. Then also, when you start considering programs, you can ask, do I meet the program requirements? And if not, what steps would I need to take in order to get me there? And also, of course, time. Do I have the time to put together a competitive application at this stage? And so when you're deciding whether or not graduate school is right for you, you can ask that question, is now the right time or should I wait? Kind of like my situation. I didn't apply during my senior year of undergrad, but I did end up applying later. And also, would I benefit from, additional coursework before graduate school that would help prepare you? Like I did some additional coursework because I switched from chemistry to environmental engineering. So during that, first year of the master's, I had to do a bunch of additional courses that were at the undergraduate level so that I could be up to speed and, have a solid foundation before really diving into environmental engineering. And then also, would you benefit from additional experiences before graduate school? So considering opportunities while you're an undergrad, like internships, doing undergraduate research experiences, either like REUs or working in a lab on a campus, getting field work experience, that sort of thing. Okay.
So now that we've kind of discussed, is graduate school right for you? And if you've answered that question and decided that applying to a program is something that you want to do, Next, we're going to discuss different types of programs that are post-baccalaureate programs. So this is one is called a post-bac. Then we're going to talk a little bit about different master's and PhD program types. And our goal today with this is just to introduce you to a lot of the terminology. If you're not familiar with graduate school terminology or different plans or different types of graduate school, we're going to briefly introduce you to those different topics today, but we encourage you to continue looking at those different programs more in depth to decide which one is right for you. So the first type of program that we're going to talk about is a post-baccalaureate program. So typically this would happen right after you finish your bachelor's degree, or if you're deciding to go, take a break before you start a full master's or PhD program. And so there's a couple different types of post-baccalaureate programs, but today we're going to highlight three specific ones. First is called a career preparation post-baccalaureate, and the timeline, this takes about a year. And a career preparation post-bac is good for students who want to transition, for example, into plant science, but they need hands-on technical training or industry experience before being like a top candidate entering the workforce of their choice. And so this one is more industry focused, but could still be a really great step if you're keeping industry or academia as a career option. Second, we have what's called a bridge post-baccalaureate program, and these can range from about 5 weeks, so before you start a program, up to a year. And these bridge programs are for students who have a bachelor's degree, but maybe lack sufficient STEM coursework, specifically discipline-specific coursework. They have a weaker academic record, so maybe your GPA is not high enough to get into a graduate program, or you're transitioning into a new discipline, like how Taymee talked about going from chemistry to environmental engineering. Maybe getting additional coursework or experience for 5 weeks to a year would be beneficial before you start your program. Third is what's called a research post-baccalaureate, and this can typically be about a year to 2 years worth of time. And this is really good for recent graduates who want research experience before graduate school. For example, say you went to a primarily undergrad institution that didn't have a lot of research experience, but you wanted to get more experience either just in a lab in general or in a specific discipline. This is a really great opportunity to get more research experience and decide, do you like even working in the lab? So these three kind of post-bac programs can give you an option to continue thinking about what's out there, what are the different disciplines I'm interested in, and before making the decision to actually start your master's or your PhD program. Next, we're going to talk about types of master's programs. So these two here are the two basic master's programs that you've probably heard of when it comes to a plant science master's degree. We have both a thesis-based master's and a course-based master's. The timeline for a thesis-based master's is about 2 to 3 years. And this is really good if you're thinking about a PhD, but you're unsure, or you're wanting an industry career with a little bit of research flavor. This can give you an experience where you're also doing the coursework. Coursework is required for your master's, but you're still working on a research project under a direct advisor. And so you get experience working in a lab, doing hands-on research. And a thesis-based master's, also, I want to note, we'll talk about funding in a little bit, but has the greatest likelihood of master's level funding. So if you want to fund your master's program, most of the time, this is going to be through a thesis-based master's degree. On the opposite side, we have a course-based master's degree, and this one is typically between 1 and 2 years, and primarily is made of coursework. Sometimes this doesn't even include a research component, but often requires either a heavier load of classwork or some sort of written document at the end that's not a thesis, but maybe an outline of the different courses that you've learned and that you've learned from. And this is good for gaining additional expertise or specialization. Say again, you want to do a career transition, maybe a course-based master's can set you up for an entirely different field. This could also set you up for an industry career if you're moving within disciplines, maybe not doing as much of a research-focused position, but you want the experience and the knowledge of getting those courses in your specific discipline. There's minimal direct research interest in this program, and often this could be covered under a combined bachelor's and master's program. We see just this course-based credential come up a lot in these bachelor's, master's joint programs because you're just adding on coursework and ending up with your master's degree. Secondly, we also wanted to cover some maybe not so popular options, or they're becoming more popular. So we have the master's degree, which is online. It's also typically a much slower paced master's. It could take up to 4 years because you're doing this either at the time that you have another job or you're balancing this master's degree on top of something else. This is good for advancing within an existing career. So if you've already, entered the plant science industry and you want to gain some more knowledge, an online degree is always an option. Balancing, like I said, continued education with other responsibilities. Maybe you're a parent, maybe you're taking care of your parents and you have external responsibilities, but still want to advance your degree. And again, this one has really minimal direct research interest. You're not in a lab, you're not doing lab work. And so oftentimes, because you're not being supplemented with grant funding or research funding, these are not eligible for a lot of funding options. There are options, but maybe not as many as a thesis-based master's. And then lastly, just a quick introduction to a master's degree that's professional. So this could be a master's of science or a master of arts, which is typically a lot shorter. It's about 1 to 2 years. And a lot of times this is either part of an internship or part of something that you do with your company. And it's good for specific career niches or industry, blending your technical and professional coursework. So this would be where like an MBA would fall under this. Maybe if you do that later on. Accelerated timelines, so a lot of fast-paced coursework, deadlines, but again, minimal direct research interest. And lastly, I wanted to note this one again, unless you're being sponsored by a company or have a direct scholarship, this one is not eligible for most university funding. So next, before we move on to talk about different types of PhD programs, I first wanted to sit and again, ask you that question of when is the right time to have a PhD? And for this or to start your PhD. And for a lot of people, this could be a different timeline. For example, you could start directly after undergrad. You could take a couple of years off after industry experience, after you finish your master's, or maybe after you do a postbac. Really, it's whenever you think you're ready and whenever you decide to apply to these programs. But today we're going to focus on 3 different main types of PhD programs. First is the traditional PhD program, which is known as direct admit. This is specifically has to do with you're entering a specific lab that you set up beforehand. You've contacted the advisor. You're not rotating through different labs because this is an option, being able to enter grad school and rotate through different labs. But you immediately start instead in this advisor's lab. You have prior contact with them where you usually know at least a little bit about the project that you're going to be working on. And you're usually admitted as a research assistant, which we'll talk about in a little bit, but your funding may change over time. And your advisor really has a lot of say in what you're doing with your project. Often this is funded by a grant, and you come in and you work in that lab throughout your entire PhD. Next, we have what's called a rotational program. So this is very commonly happens within a departmental program, but can also happen in an interdisciplinary program. So during these rotations, they could typically be 1 semester long or 1 year long of rotations. So you'll rotate through 3 to 5 labs of your choosing. Sometimes this involves prior contact, but we also know of other universities that suggest maybe not contacting a PI. And then as you go through your rotations, you're learning about the different projects that you could be involved in. And also, this is a good time to ask different questions about how this funding is covered. Maybe someone you're very interested in joining their lab and you rotate with doesn't have funding. And so it gives you an opportunity to look at different options within that specific department and what you want to do. Do you vibe with the lab? Do you like the lab mates you're going to be working with, etc.? And so time during your rotations is usually covered by your department, but after that, there are different ways that this could be funded. And it typically has additional degree requirements, such as those rotations, but could also be coursework or internship requirements. Next, I wanted to highlight an interdisciplinary program. So these have become a lot more common. And they're usually interdepartmental programs, but they can have rotations or they may not have rotations. Similar to a rotational program, you would rotate through a number of labs if it offers rotations, and then decide at the end of that which lab you would join. If you join an interdepartmental program that doesn't have rotations, you would still be kind of under a direct admit style of situation, but it typically requires coursework from multiple departments or multiple internships. So there are a lot of times other requirements that need to be met that are outside of your specific department. Say, for example, you join a lab in the botany department, but you're part of an interdisciplinary program. There would be additional requirements on top of the botany coursework that you would need to do that other botany students may not have to. And so funding, again, just like a rotational program, it's usually covered by your department or home department or the interdisciplinary program. And then after that first year, the funding type may change and you may not understand what type of funding is available when you join the interdisciplinary program. So after looking at all three of these different types of programs, I wanted to highlight that there is marginal variation among these programs, especially with alum institutions. And so being familiar with all of the options and the terminology is really helpful when you're looking at programs and knowing what questions to ask. When it comes to funding, when it comes to resources, when it comes to working with an advisor, reaching out to a different advisor, all of these come down to very much within the different plant science department or plant science adjacent department. If you're joining something like biochemistry or microbiology, these different programs exist, and it's always good to look into which type of program that you are interested in. The rotational program, for example, I was very interested in only applying to rotational programs as a graduate student because I wanted to know, coming out of my bachelor's, that I was making a decision to be in a lab that I wanted to be in and that the research was something that I wanted to do. So getting experience in those 3 different labs that I rotated in allowed me to really understand which discipline I wanted to focus on.
So now that we have laid the foundation of all of the different types of programs, it's important to consider the additional requirements that those programs may have for graduation beyond the obvious research requirement, depending upon what you're doing. So, like BeKa said, coursework requirements will vary based on the program, but knowing what courses are expected is something that can be really useful and should be researched prior to applying, because that can help determine if something like a post-bac is useful, or, if you do a master's first and you have a master's, if some of those courses may transfer into. So, figuring those out ahead of time can be a good move. Some programs, may even have an internship or some kind of service requirement. And the options that can be really common, such as, in the first year, all grad students are expected to help TA a large undergraduate course. I know that happens a lot in chemistry. Everyone TAs their first year, and then you may TA beyond that throughout your program. But for most graduate programs, especially those that are thesis-based, like a thesis-based master's or a PhD program, there's typically some type of examination that's required that serves as a metric for potential success and completion of the program, such as, qualifying exam or quals, comprehensive exams. The name that is used depends a lot on the program, but a tip for finding out the expectations then is to look up your graduate program's graduate student handbook. So those are often available online almost always, but if they're not immediately available, you can reach out to the department and see what those requirements might be because it varies so much. You can usually just reach out to an admin and find out, what may be expected of you. So all of these different, types of exams, the name depends on the program. So we're just gonna kind of speak in generalities, and that's why looking up what particular requirements are expected. But then when we look at the first exam type, which is often called a qualifying exam, this is often used to test the foundational skills and then kind of your baseline potential for conducting doctoral work. So these are often typically in PhD programs that you would see these types of exams. And they can take place, this type of exam would usually be at the end of year one, maybe year two, and they can be in the form of like a written or standardized test, or, possibly even the defense of a really short research plan. But test is kind of, just a quick deciding factor for your department if, you are eligible to continue on in the program before they continue to invest in you, especially in a PhD program. For the second type of exam, I call it a comprehensive exam. It's kind of meant to show you that you understand a wide range of topics related to your study field. It could happen a little bit later, but again, it depends where professors or your committee may ask you, deep questions where you'll have to say those to your committee and answer those, and also really long, written essay prompts. So this one's usually more of a writing based type of examination. And then when you look at the third type, it's often called a preliminary exam, and those are very common, in PhD programs. It's meant to check if your early work that you've conducted up till this point and your foundational skills are strong before you begin your final thesis. So this can happen either early in the program. Some programs have you do this really early on, especially those that may not have the same qualifying or comprehensive exams in addition to the preliminary exam. Or this can happen, towards the end of your program before advancing to like official doctoral candidacy, which is when you move from, doctoral student to a doctoral candidate. It means all that's left you have to do is your dissertation research and write your dissertation. So these, like I said, these are primarily in PhD programs. Some master's programs may have some form of comprehensive exam or some type of test to see if your thesis-based research is ready for defense. I know when I did my thesis-based master's, I did have to have like kind of like a mini committee defense early on to see if the research that I was going to do in my master's would amount to a master's degree. So they do exist. All right.
So now that we've kind of gone over some of the different types of programs and the different program requirements, we have some questions to ask our audience or questions for you to think about as you're going through this process. So for example, what are the program course requirements? Like Taymee said, there are different course requirements that are usually, every department has their own course requirements, but specifically, what are the course requirements for you to graduate? And how does that lay out your early PhD stages? Another question to ask would be, what's the average time to completion for this lab or program? This could tell you a lot about the lab or program that you're joining. Does it more of a 4-year lab or more of a 6-year lab or 7-year lab? And how productive is this time? What does your advisor think that you need to graduate? Are there additional certificate opportunities, such as a teaching certificate? I'm someone who has always really wanted to work at a primarily undergrad institution, and so I took advantage of a lot of the teaching opportunities that Purdue had while I was there. And so looking into, those career-specific goals and professional development goals that you have and what's available at the university is really important when deciding on a program. On the opposite side of that, I was focusing on teaching. Some schools have really great industry connections. So ask around, ask people in the department you're looking at, or PIs, or overall who works with these departments. Do they have specific industry connections? If you want to work at a specific company, look at the company collaborations with the universities that you're looking at. And so that's really important when you're thinking about the long term. Like a PhD is not just a 1 or 2-year thing. You need to think about your professional development as a whole person, as a whole scientist over this time. So also you can ask questions like, what courses are available to me? Maybe not what's required, but what other things can I learn while I'm there? This could be a balancing act between what your advisor wants you to take outside of the required coursework, but also what interests you and what kind of things you want to learn. If you're doing some sort of machine learning or a lot of statistics, make sure that those courses that you're interested in are available and that you can take them. Also, what campus resources are available for you outside of your lab? What different instrumentation is on the campus? What collaborations are on campus? What different personal resources are there on campuses? Are there cultural centers? Are there writing centers? How do you plan on using those? And think about what kind of resources you need to thrive as a grad student. Also, what does compensation look like living compared to living costs, right? Are you going to take a stipend? Is your grad organization unionized? These are all questions that have to do with your quality of life as a graduate student. And then lastly, what does the funding timeline look for this program? A lot of times graduate students will enter their program and they'll know what their funding looks like for maybe the first year or the first 2 years, but they don't really fully understand that the different types of funding can change throughout their course of graduate school and what those different funding types look like, which kind of leads us into our next section.
Yeah, so next we are moving into the different types of graduate positions and then the funding sources that are available. So we've kind of laid the foundation of whether or not we want to go to graduate school and then also what those different programs might look like. This is, answering if you are in the program, how will you ensure that, you are paid? So next slide. So when we were looking at internal versus external funding, one way that you can fund your graduate education is through something called a graduate assistantship. So these are often offered, through your department, by your university, or different centers on campus. But essentially, this is a way that you have your salary paid. So these are usually salary-based positions where you have a paycheck. And in addition to that, you also would have typically free tuition. Sometimes other benefits are built in, departmental benefits or access to like travel funding for research. And these can also be a part of an admissions package. So when you apply to different, universities for different programs, these can sometimes be offered, for recruitment to try to bring you in so that you join their program. And another common means of finding graduate school that I would say it's probably one of the most common, especially if you're doing something like direct search assistantship in and they fund your salary through their own grants and funding sources. These are also usually tied to a grant, so your deadlines and research expectations can be related to those. These are often, on a 12-month employment basis. So that might be that you join direct admit and your first year is through a research assistantship while the grant funding is available. Then a third type of assistantship is teaching assistantship. So most graduate students, like I said previously, will TA at least once during their graduate education. The number of times that a person TAs or serves as a teaching assistant to a professor, it can be dependent on the department, your PI's funding, if there's, a lapse in funding and you end up TAing at that time, and also the program if there's a program requirement. So as a TA, you're typically, beyond the research that you'll still, typically be doing and, making good progress on your research for your thesis or dissertation. You'll also be, assisting with lecture, lab courses, and doing those other responsibilities. Then a fourth type of funding is through an external fellowship. So these tend to be more lucrative and can carry some level of prestige depending upon what type of external fellowship you receive. And the compensation can vary widely. Some, just cover tuition, but a lot of times they often have enough funding so that your tuition's covered, but then you're also having that salary like you would have with a graduate assistantship, research, or teaching assistantship. And it's often administered as an assistantship. So your fellowship funding would be sent to the university so that you can be paid, through a W-2 as a salaried stipend. Or sometimes you can be paid directly, depending if your university allows it or if that is the type of funding source that they have set up. And there's also, in addition to that, with external fellowships, usually some fellowship-related obligations that you end up completing beyond your program, like service to whatever organization is helping fund you. The next slide. So every person's experience through graduate school is different, and your funding can and usually will change. So this slide is meant to show two different examples of potential ways that a student could be funded during a PhD. So for person one, they may go into the program with departmental and rotational funding already built in. So this can be common in the plant sciences, to my knowledge, if that rotational setup is available. And then let's say during their first year, they applied for the NSF GRFP, which then could, if they receive that or receive some sort of external fellowship, it funds them while they continue to take courses, do their different comprehensive exams, preliminary exams over the next 3 years. And then, looking at year five, maybe they are, they have a departmental requirement to TA or they choose to TA for teaching experience. So then they do that for a year. And during that year, apply for dissertation writing fellowships to then wrap up their PhD and finish writing the dissertation. So then for person two, they may have joined a lab where the PI had a grant and they were, heavily recruiting a certain, like undergraduate student who has some type of research experience. So they begin, direct admit under a research assistantship and continue doing that for 2 years while the funding is available. And then during the third year, they, choose to TA or their PI asks them to TA while they're searching for additional funding to fund research. And then, later they may have decided that they're interested in industry and found an industry sponsored fellowship that funds them a year before TAing again. Maybe they really like TAing the course and then that worked out with their funding. And then, it can vary widely depending upon what lab you join, what institution you're at, what program you're in, and there's no right answer. It's different for everybody.
So now that we've talked a little bit about funding, fellowships, and different types of graduate program requirements, we also wanted to introduce you to some different additional types of funding, including fellowships, but some terminology and how you can kind of navigate this as a graduate student or as you're looking at different graduate school things. So Taymee and I were really lucky to have a combination of all of these grants, fellowships, and scholarships during our entire graduate school experience. And so I'm just going to briefly go over kind of the differences between these different types of funding. First is grants. So grants, what they are, the funds that are provided for a specific purpose. Often these are usually project-based, they require a proposal, but they can come from different sources such as government, private foundations, universities, or even your favorite biotechnology companies. So I put some here, the different types of grants that graduate students can think about, applying for while they're in grad school or as they're starting grad school. One, research grants, the most basic, right? Specific to a research project for equipment or experimental supplies. There's travel grants, which are funds to attend conferences or workshops. There are also project grants for community service or industry collaborations. I was fortunate enough to receive a project grant to work with a community garden during my time at Purdue. And then also there are things called training grants. So these grants support a specific type of training at a university. And I wanted to take a moment to highlight this because I don't think a lot of people really know what these training grants are. So these grants are usually short-term, 1 to 3 years, and they're managed by a professor or a department to support a specific type of training. For example, I was in the quantitative plant pathology program at Purdue, but that program only existed for a couple of years. These training grants are a great way to find programs for your graduate degree because they come with specific funding. Note that you are not writing the grant proposal in this case. These have already been funded to a PI or a department or an interdisciplinary program to fund your different your training. And so as part of my role in the quantitative plant pathology program, I had additional requirements like internships, teaching experience, reports that I had to write for my internships experience. But here there's just a list of different grants that I would suggest looking at if you're interested in looking at schools with these specific training grants. Next, fellowships, which we've talked a lot about today. They're merit-based awards for research or your degree that frequently include tuition coverage plus a stipend. So these full fellowships typically include tuition money, your monthly stipend, so a paycheck, access to health insurance. Usually there's a partnership with your institution where you get access to insurance or additional benefits if you bring in the money. But one thing I wanted to highlight is that I think fellowships are really important for research independence. Getting a fellowship means that you're setting your own schedule, you're building a project that you're interested in, and that you are taking the driver's seat in your experience as a PhD student. You get these experiences if you're working under a PI, yes, but a fellowship is kind of an elevated way to show how you're independent in your research, your grant writing, and overall your projection as a scientist. So some different options for full fellowships are academic fellowships, which are awarded based on your scholarly achievement, professional fellowships, so these can be sponsored by industries or organizations, and then also institutional fellowships. So these are provided by universities, but are usually beyond just your department. You're nominated for this, or it's part of a specific program that you're a part of, and it will cover a year or 2 years of your funding as a fellow. Lastly, scholarships. I'm sure we're all familiar with scholarships, but mostly what they are financial awards based on merit or need. Characteristics of a scholarship are they can be one-time or they could be recurring. They're used to either help cover tuition, or if your tuition is covered, they can help with other educational expenses. And they're usually administered through the financial aid office. So there's a couple different types of scholarships. We have merit-based scholarships, right, based on your academic performance or achievements. We have need-based scholarships based on financial need. And then we also have specialty scholarships, right, for underrepresented groups, specific industries or disciplines. Oftentimes, you're doing the work, seeking out different scholarships that you qualify for to be able to have more research funding, cover your tuition, or even just have a higher, income compared to whatever stipend you're making. And so scholarships can become a really important way that you can fund yourself as a student and as a scientist, and get experience writing for different things. I would also suggest, if you get the opportunity, to serve on a scholarship review committee if you can. Getting to see what good scholarship writing is really important. If you want to be someone who's writing scholarships, fellowships, grant applications, seeing what other people are writing can help you understand what a good proposal or what a good scholarship looks like. So now that we've kind of broken down those three different things, I just wanted to highlight the key differences between grants, fellowships, and scholarships. So grants are usually focused on specific research or project goals. Fellowships are focused on academic merit and development as a scientist, and scholarships are primarily based for tuition, based on merit or need. So kind of what we've discussed today overall, is grad school the right move for you? Think about that and determine if graduate school is something that you need to do, want to do, or should maybe wait and try to figure out the different types of programs, navigating those, what's best for you again, post-bac, master's, PhD, what are your career goals, and then overall different types of funding that you can have as a graduate student, whether that's your specific position type of funding or scholarships and grants.
Yeah, so thank you for listening to everything today, everybody. It's been wonderful to share with you some of the uh, different ways you can fund your graduate education, what that looks like, and whether or not this might be for you. So if you're curious how to start your graduate school journey, depending upon, no matter where you are in your undergraduate journey or, if you've graduated, be sure to check out our Gateways to Graduate School website. So this is based on the course that BeKa and I put together and instructed while we were doing our PhD at Purdue. And then we turned it into an online resource. And the link just went in the chat too, or you can, or the QR code. So be sure to check it out. And it kind of goes over, your first steps if you're just looking at programs, reaching out to faculty, different application resources, when you're preparing a competitive application, putting together your personal and research statements, making sure you have a solid CV, and when to reach out for letters of rec, how to prepare to interview, and then some, general resources. So this can be another way, beyond it's great attending today and, hearing all of this, but you want to make sure that you do a lot of targeted research, learning about available programs in graduate school in general so that you can tailor the experience to your own interests and your own career goals, before taking those next steps. So, yeah, thank you all for your attention today.
And so now we're going to take, if anyone has questions, feel free to raise your hand or put them in the chat. We just wanted to put one last plug for anyone who's still out there to join our community. If you're a grad student or if you're interested in graduate school, you can find more information on the plantgrads.com website, or if you have questions, you can email plantgrads@gmail.com. Again, I put all of the links in the chat. If you're interested in more information about graduate school, please feel free to share this with anyone that you know is interested in grad school. These resources were built to be open access for anyone interested. And I, Taymee, and all of the PlantGrads leadership team really thank you guys for tuning in today.